I'm Jeff Johnson, and I'm the lead developer at rpm5.org, and also part of the Mancusi project. You just saw me meet many of the other members, essentially for the first time. I'm a remote since I live in the U.S., but Mancusi is the best research I've seen on package management, since forever. Okay, with actually analyzing and modeling and looking at the details of package management and trying to scale package management into hundreds of repositories and thousands of packages, and trying to make sure that the fundamental goal of package management, of software installation, is actually functional. Okay, so I recommend Mancusi, not just because I'm part of it, but it's the best research I'm aware of, and they're the only attempt that I know to approach Debian and RPM packaging, neutrally. All right, for the last decade, there's been an insane amount of effort wasted just because of packaging war differences. Okay, both of them are successful, RPM and dpackage, and they're just different. Okay, and they're more alike than different these days. The same problems are being solved. It's just one person says banana and the other person says tomato, but it's the same intrinsic problem. In any case, my talk is pretty much ad hoc. I have no slides and so on. As a developer, I tend to have too many notes and not enough music, and I promised certain members that I wouldn't be boring. This is my third talk here at FOSDEM. My first one, I made the mistake of providing too many details, and I put a whole room to sleep. All right, but my second talk, I found that it was easier to find essentially 3 to 5 talking points and try and convey an overview of a very complex subject. The subject here is transactionally protected package management. And those highfalutin words basically just mean trying to add ACID behavior to make packaging more reliable. ACID is well known, and if you are adding transactions to a database, the essential components are well analyzed. ACID, for those who don't know, stands for atomicity, consistency, isolation, and durability. All right, and atomicity is usually achieved by locks. Almost everything has it. Consistency, if you're inconsistent, well, you die fairly quickly. So those are the rather easy aspects of ACID. The parts that need to be added to package management are isolation and durability. Durability is perhaps the easier one because it just adds persistence and a persistent state machine on beyond just the action of an install. Package management is different from archivers because it tries to manage software over its entire life cycle, okay, from building into distribution, into installation, into retiring it, and legacy compatibility. And so durability is trying to add a persistence to the store of the metadata on the installed machine so that it's known reliable and it can be maintained in a consistent fashion. So isolation is rather more complicated because of the mixed problem case that a package manager has. There are basically 3 different types of information that need to be preserved when a package is installed. The easiest one, because it's an already solved problem, is the database ACID. Databases have ACID. We all know this. The second one is file systems. And file systems is where isolation becomes very tricky. A file system, by its nature, is shared. I mean, there is no file system that really has any credible approach to isolation. What isolation is two processes shall not know, that they're both about each other. There shall be no side effects that are shared. But that isn't how file systems work, all right? File systems try and provide a consistent viewpoint onto a data store on a file system, and so another entity will see a file as soon as it's created. Since a package manager is installing on a file system, isolation is rather tricky to achieve. There have been several attempts to do this with, let's say, file snapshotting or copy on write and aspects like this, but ACID will never be fully achieved on a file system until the file systems themselves start providing some sort of transactional protection. Actually parked, and this is probably an appropriate place to point it out, as part of doing due diligence on whether transactionally protected package management was feasible, one of the things I looked at is the two attempts that I'm aware of to try and do transactionally protected system calls. And one of them is the Valor file system, and this is the third implementation that is starting to perform nearly as well as ext3. It's only 3 times slower. But when you add the logging necessary for transactions and transactional rollbacks and two-phase commits, you're going to write more information. And so actually a factor of 3 slower is not too bad, all right? But the Valor file system has transactions built within a kernel driver and the benefit for a file system is all sorts of race conditions are avoided if you can provide the I in ACID isolation. All right. The other approach, which I'll just mention offhand, is I think it's out of the University of Texas, and it tries to provide a begin and commit on a transaction around sets of operations. That's a second approach to essentially the same thing. Unlike a file system, okay, a package manager speed is not as critical. RPM is not going to be compared to ext3. It will be compared to dpackage. Okay, but dpackage is slow enough that it's possible to try and provide some isolation that on file system operations, all right, which is the second component, if I recover all my parentheticals. There's ACID for databases, there's ACID for file systems, and the third part is the part that John Thompson talked about this morning, which is ACID for scriptlets. And that's a really hard problem to solve. But the second component, where isolation is very tricky, is how do you preserve all the system calls that are done by a package manager as it's installing content on a file system. All right. And just to summarize, a rather complicated and roundabout way of talking about it, until a file system provides isolation, RPM can't. All right. But RPM does do things like installing files in a temp name and then renaming them in place. If the temp name is unique enough, it's unlikely that there will be an interaction between two interacting processes. But that's about the best you can do, with transactionally protected package management is install into a unique name and then try and move it into place as easily as possible. So the three components for transactionally protected package management are database ACID, system call ACID, and scriptlet ACID. The underlying mechanism is quite complicated, but it's not hard to understand. If you want a transactional log, you have to write a log record before you perform any operation. And if you have a log record, then you can also put a marker in the log that indicates that you completed successfully, and if there is no marker, you can infer, go back to previous one. And that's essentially what happens with a rollback. Once you have that basic state machine for transactional logging, then the rest of it's rather easy. It's just moving between different, consistent points. And anything in between, can be inverted and discarded, which removes side effects. This will be one of the major benefits. I know it was one of the very first things I was asked, can RPM5 truly, if there's two headers in there, will the other one disappear? Okay, and this is one of the side effects. If there's an abnormal exit in the package manager, then there will be residual state that's left. And this often shows up if you do a query, you'll have both the old and the new because you failed before the old could be removed. All right, that will now be transactionally protected, and if that install erase pair, okay, does not achieve a commit, then the intervening information can be discarded reliably, so that the underlying store, okay, is known to be moving through time by definite checkpoints, all right, with known good behavior. Most of the rest of what I'll talk about, and the part that's complete now, I believe, although the really hard part about transactionally protected package management is to know that you have full coverage over all possible cases. That will only come with sufficient testing and usage. But what is there now is using Berkeley DB, all right? RPM already uses Berkeley DB since all that transactionally protected package management relies on is ACID behavior. Any database would do, but Berkeley DB already has all this. And so there's no reason to look at alternative forms, but any SQL database these days provides some form of ACID behavior. The choice at RPM5 was to use Berkeley DB. The underlying reason for this was Berkeley DB already has sample code that shows how to extend the database logs into other abstract events. Other abstract events, the sample case that's in there is if you have two system calls, make dir and remove dir, they form an invertible pair. Okay? While you're installing, you make a directory. But if you want to roll it back, you remove a directory. And so it's very important that every action has its own inverse. But with sample code and an awk script that generates all the glue layers, it's possible to extend Berkeley DB to handle system calls. RPM itself, during package installation, performs about 20 system call operations. And there are things like make dir and remove dir, and of course, writing a file. To extend Berkeley DB ACID to file system ACID, if you're going to remove a file as part of installing a package, what needs to be done is to write the previous content into the log and then remove the file. So if you have to put it back, the content can be put directly back out of the log. Nothing else is needed except the log and something which can read the log. So my goal with transactionally protected package management, and I'm not there yet because there's a large number of pieces that still need to be implemented and tested, is to take a machine, take the log off it, take the executable which reads the log, remove everything else, and put the machine, the entire machine, all state on the machine, every single file exactly the same, using only the log. All right, that's the goal of this. All right, because RPM is expected to run in empty change roots and on bare metal machines, and there is no stronger test of it, a test of any implementation than can you recreate anything, everything that's on the system, and pass a diff test to make sure all the information is identical. I think that that is feasible, but I won't know until I actually get there. Yes?
Sorry, a couple of questions.
Sure.
The goal is remarkable for a system point of view or user point of view. For the camera, the goal is remarkable. There is a lot of good behind what everything you're saying, but in order to do all this protection, how much overhead do I put over my file system? If I'm installing 20,000 packages, that takes 40 gigabytes, and then I need to go and restore from the logs, it means that I need to have at least 40 gigabytes of logs, depending on how many times I've been updating in between. So there must be some kind of optimization you have in mind to avoid that kind of overhead on the local machine.
You give me a perfect entry point to describe, what I've been working on for the last 6 months. There's a number of problems with the schema that has been used by RPM for years, all right? And I've never really been able to tune Berkeley DB performance to try and minimize the overhead that you're mentioning. So a large part of the work was preparing the infrastructure to take in a Berkeley DB transactional machine. But in order to succeed at that, I have to be no slower than I was before. So I had to fix a lot of the flaws in the current schema. I've achieved at least a tenfold improvement in performance, which, since for logging operations, you essentially have to do everything twice, write once the log and once onto the file system. Well, 10's bigger than 2. The way that this has been done is to, Berkeley DB will use an mmap to move information from the database. RPM also does mmap.io. So the second copy is not that expensive, all right? Almost all of the overhead of reading a database, once the resource cap is changed to permit, up to, let's say, a quarter of the machine to be memory mapped, the I/O overhead on a database largely disappears. Writing to a second location from a memory map is also not that significant in overhead. There is still the cost of the log itself, and writing content in the log, if you actually try and preserve those logs over time, it becomes quite significant. At the moment, what I'm doing is every successful RPM operation creates a checkpoint. By creating a checkpoint, I'm establishing a base that determines how far back in history do I want to go. And clearly, nobody cares what was done on a machine 1 year ago. I mean, people care, but not most users. all right? And you don't need gigabytes of logs, going back forever in most cases, okay? The cases where you do care, I mean, it's important and you'll allocate resources to maintain those logs, but not for an end user machine. What I'm seeing is that by paying attention and changing the schema, and I'll describe some of the details in a moment because that is the most important point, and things like rebuild DB are not the right thing to do if you have a transactionally protected database and are no longer necessary either. What I'm actually measuring is that it's quite feasible to switch from the concurrent access model that RPM is using now to a transactionally protected module if the schema changes at the same time and there's measurable increased lock overhead, but the overall wall clock measurements are about the same, and the saving the previous transaction is probably a tolerable saving, so that if you have an interrupted action that you can restore the metadata store and take out the side effects of a broken install is probably worth the effort. But that's not for me to say. This is my opinion, okay? Yeah. I mean, and I do have deep mixed feelings about logging and transactional protection. There's basically two approaches to trying to improve reliability. One of them is what I'm talking about, where you have a log on the local machine. The other one is called, I call it provisioning. And that's basically you take the state off the machine and put it someplace. This is basically what Red Hat Network does. This is the sort of Google model, and I call it provisioning because you can always recreate the machine. And provisioning as an approach to the same problem has two major benefits. First of all, it's always off the machine, so you never have to worry about hardware failures and things like that. And second, it's usually centrally located, which minimizes the maintenance cost of it. The disadvantages of a provisioning approach is you often don't have the sufficient number of details to track all the detailed state. This is better done on a target machine, on a client machine, and with a log. There's a balance point someplace between those two, all right? But RPM and package management in general is a client only. It's not tied to a server. So I'm solving that problem, but the other one exists, and there's nothing better or worse with it. Does that answer the question?
Yes, absolutely.
Okay. Since I just described the two sort of general alternatives, provisioning versus transactional protection, I probably should say describe some of the other approaches. One of the approaches has been from Nexenta with ZFS, and Yum in Fedora is attempting to use BitterFS and file system snapshots. These are definitely viable approaches. The problem is that if you're going to use something like a ZFS or BitterFS snapshot, you first are stuck with some of the artifacts of being a file system. ZFS, can perform snapshots per mount point. Okay, a package can install on several mount points, and so you have the snarl of package side effects across multiple mount points that makes it more complex than otherwise. The intrinsic flaw is if you're going to use a file system approach, to let's say minimize, the number of writes or overhead or something like that, is that you must have that file system in the kernel, and neither BitterFS or ZFS are sufficiently widely deployed. RPM5 runs on every Unix in sight. It's not in Mac OS X and lots of other places, and I'm finding myself talking to people about even doing RPM on Windows. Okay, you can't bet on things like BitterFS or ZFS, as a general approach. That's part of the reason why I decided to just use Berkeley DB rather than to rely on a snapshot in a file system. A snapshot is basically a cheap, it's essentially a checkpoint on a file system with a copy on write attached. So at the checkpoint, the current state is known, and anything that changes from that point, is tracked separately with some sort of overlay, if you will. And that's the way I picture like a file system snapshot. A log internal to RPM is essentially the same operation. The real difference in the performance measurement is basically what you choose to count, or how you choose to count the resource usage, like clock ticks or number of blocks of I/O. But all logging approaches are going to be the same. You have to write a copy before actually performing some operation. But the point I was trying to make is that transactionally protected package management is not the same as a file system snapshot. These are complementary approaches to essentially the same problem. Another thing that transactionally protected package management is not about is, let's say, a representation of the log. If you're trying something like the modeling that Mancusi is doing, you often have to try and come up with a reasonable format. CUDF is one. I'm quite sure that there's another one coming from Mancusi Work Project 3 that describes the elements of a rollback. Each one of these is a different format. Each one of these is a different representation of the same information. But describing things differently is in a different type of markup for different usage cases is not exactly what it's a different meaning of log, okay? And that's not what I'm talking about with transactionally protected package management. The state machine for rolling back a transaction is actually quite different than a package state machine, which does erase the old package and update with the newer content. So the log is pretty much internal, and the representation can always be retrofitted later. Since I'm reaching about 15 minutes, let me go through some of the details that have already been implemented with database rather shortly. But one of the important elements is that there are tools that are going to be needed that will be external to RPM. The most important, if you bring nothing else away from this talk, if you're trying to use a transaction model, rebuild DB won't help you. But the alternative is DB recover minus EV. All right, since most of the world is fixing RPM side effects by attempting rebuild DB, it won't hurt you, but it's not going to save you. DB recover will. The log management, and particularly the checkpointing, which is the most important element at reducing log size, is the tool needed is DB checkpoint. And that puts in a boundary which in time that says this is the last known good. To get rid of older logs, the tool is DB archive, and these are, you will need tools to manage your database. I haven't yet even considered the question of compatibility with older versions of RPM. Compatibility is going to be rather tricky because essentially lots of the elements that used to be in RPM no longer exist. Most specifically is there are no join keys. These are integer identifiers for packages that were monotonically increasing. And since those don't exist, I'm not sure how compatibility can be meaningfully defined. I hope to do it by providing conversion. Conversion from one to the other is an acceptable way of achieving compatibility, but that's not the same thing as interoperable compatibility. All integers are now saved in network order. This means cross-platform is now meaningful. Previously, RPM saved in native order all the time, but network order permits binary strings and integers to be dealt with equivalently using a mem compare, which is important for B-tree access, and that also is a performance increase by switching to network order. One of the other incompatibilities that's been introduced is that Berkeley DB provides a counter that does that monotonically increases. Previously, this was done with a weird hack by using record number 0 in the primary store as if it were an instance counter. By using a persistent number, there's now an identifier that is durable over time. Some of the other performance improvements is I'm now able to do pattern retrieves on keys, which means this is much higher performing than what RPM has done in the past, which is a secondary lookup with a header load and marshalling and signature checking that the actual database side effects of the retrieval, this is where most of the performance improvements that I've achieved reside. One of the other sort of deep fundamental infrastructure changes is that signatures and digests are no longer verified. The actual, there hasn't been a problem that has been detected with a signature or digest check on a database blob for quite some time. And so what I'm doing instead now is using mmap and prot read to protect the blob when it's read. Okay, there's pretty clearly no reason to verify the digest and signature on a blob of binary data that is hardware protected. And that removed a very large amount of overhead reading headers from a database, and is a big chunk of the tenfold performance improvement that I've gotten. That's about, because of time, is I'm much more interested in questions. If you want me to continue, I can go into some of the way that scriptlet acid will be achieved, okay? Having heard John Thompson's talk this morning, okay, that rapidly got changed since 10 o'clock this morning, but I can try and flesh out some of the details that I think where the connection between the work that Jim Thompson and Paulo and Caixa Magica are doing is going to fit into this. Or I can also just try and field some questions. It's up to you. Are there questions or? Yes.
Yeah, I have another question. How important it is for you backward compatibility? You mentioned that the new version you are developing now of RPM breaks compared to the old one, or you need to provide a method to transition from one to another. Isn't sometimes that necessary to just break and say, no, we start clean, so to speak, and move on?
Well, compatibility depends on what's being talked about, and as does break, all right? And I'm not trying to break things without reason, all right? Most of the problems with the RPM schema I've known for a long time, and I've lived with that. But yes, there's times to break. I've just been notified 5 minutes, but any other questions? Okay, there you go.
Yeah, hi. So I might be a bit off here because I'm not really involved with RPM distribution, but as I understand it, it's also an option within RPM to do scriptlets installation. Maybe you covered this. So how do you plan to roll back those scriptlets? They may be creating files, they may be doing stuff. I don't know.
The talk by Jim Thompson, John Thompson this morning was about using a DSL to break a scriptlet into smaller pieces, all right? The fundamental problem with scripts in packaging is that they're too coarse-grained and they're opaque. You know, you have the general case is you have side effects, and the side effects need to be captured somehow. The benefit that I see from the DSL is that it will be possible not just to look at the exit code from a script, which is all the information that is being returned, but it will be possible, it was even in one of John's examples, that he illustrated that there were two operations within a single scriptlet. And that's fundamentally the problem. If you have like a configuration change and a daemon restart and other side effects, you know, it's possible to have one of them fail and it being unimportant, while the other ones are absolutely essential to the operation. So by having finer grain, then it becomes possible to come up with partial failures and partially invertible failures. The other benefit will be in simulation and modeling, okay, because scriptlets are often in shell. It's painful to do anything other than de facto testing of the scripts. By simulating and modeling other properties, such as ensuring that prerequisites that aren't specified in the ordering of the package are actually met. And what I hope to do is to use that DSL, breaking it up into smaller pieces, and map those pieces into a log as a starting event and a failure event. The other more traditional approach is scriptlets run in an environment, and that environment needs to be captured in the log. Okay, what the environment variables were, okay, what the prerequisites are. To some extent, that provides a level of acid and invertibility, all right? The problem is that this is a general programmatic language, and so things like typos, cannot be tolerated, all right? But these are not very interesting problems. They are important problems that have to be solved, but it is a very hard problem to get acid underneath scriptlet behavior. Does that answer the question?
Almost. There's just one more thing, actually. What I basically meant is if one of those scriptlets creates a file or updates a configuration file or whatever, and you figure out later that you need to undo the upgrade for some reason, then you should basically maybe also undo what the scriptlet did.
Sure. Scriptlets need to be invertible.
Yeah.
All right, and there needs to be an undo.
That's what I mean.
The same invertibility happens when you install a file. I mean, if you're writing content or you're removing a file.
Yeah, but there's probably some way for the scriptlet then to communicate to RPM that, hey, I've modified this file, or is that way? I don't know.
A better communication will be the the means by which ACID is achieved under scriptlet behavior. All right.
Oh, right. Okay. Right.
And it's the same basic effect that you log any operation before it's performed. The complexity comes solely from using Bourne shell, which is painful. All right.
Right.
And embedding is another approach that could be used, like either embedded Lua, and then RPM is more aware of the actual operations are there. But the general approach is just to use the 55 operations in Deb Helper and to parameterize those. And that's a perfectly sound starting point because that's the order of magnitude of the side effects of package management. And this isn't a large corpus, okay?
Gotcha. Right.
Any other questions? Yes.
What do you think about the NixOS package management system, which is a purely functional way, and which
like
avoids most of the side effects?
I like it a lot. I've been talking to Eelco. I started about a year ago, and from a package manager point of view, the single biggest failure mode at the moment in packaging is scripts. Buggy scripts, that it's not only buggy, but scripts that aren't written generally enough. All right. And my private view is that I need to remove all scripts from RPM. If I say that in public, and I didn't say it here, okay, if I actually remove all the scripts, I'm going to also appear to remove all programmatic means to change packaging. Okay, this is the same decision point that everybody faces switching to a functional model. You have to think about the problem space very different. All right, but from a package manager point of view, I have two alternatives. I go the Nixos route and I say no scripts and everybody hates me, and then I retrofit the same actions, okay, through other means. Or I take a slow and gradual approach to a functional. Okay, where the first step is to use Deb Helper, and then to break Deb Helper into smaller pieces, and moving gradually towards refactoring code, fewer side effects, and eventually achieve a functional model. I don't know what the answer is, but I like Nixos a lot.
Is it something that you are going to try in Mancusi project to tend?
I can't speak for Mancusi, but I have tried to talk to the Nixos presentation. I haven't yet found it, but and I have considered this. The approach that I will probably take will be to embed Haskell and try and do Nixos package management directly from RPM, and to see whether that approach is viable. All right, but I'm well aware of what Nixos is, and I like functional programming. I don't do it, okay, but because it's just too hard to switch from one to the other. I live in the real world, and I'm a C programmer.
Thanks.
But, okay. Any other questions? Time? How'd I do?